Rendering pipeline in JavaFX. Uh, Here you can see rendering pipeline primitive. You can see here primitives and here graphics 3D, 2D, and output devices. In graphics through 2D, the rendering process can be broken into 4 phases that are controlled by the graphics 2D rendering attributes. The renderer can optimize many of these steps. Either by caching the results of the future calls or by collapsing multiple virtual steps into single operation, or by recognizing various attributes as common simple cases that can be eliminated by modifying other parts of the operation. The steps in the rendering process are: 1. Determine what to render. 2. Constrain the rendering operation to the current clip. The clip is specified by a shape in the usage space and is controlled by the program using various clip manipulation methods of graphics and graphics 2D. The user clips is transformed into a device space by the current transform and combined with device clip which is defined by the visibility of windows and device extents. The combination of user clip and the device clip define the composite clip, which determine the final clipping region. The user clip is not modified by rendering system to reflect the resulting composite clip. Determine what colors to render, and step 3. And step 4, apply the colors to the destination drawing surface using current composite attribute in the graphics 2D context. There are 3 types of rendering operations. Along with the details of each of their particular rendering processes are shape operations, text operations, and image operations. In shape operations, step 1, if the operation is a draw shape operation, then the create stroked shape method on the current stroke attribute in the graphics 2D context is used to construct a new shape object that contains the outline of the specified shape. Step 2, the shape is transformed from the user space to the device space using the current transform in the graphics 2D context. Step 3, outline of the shape is extracted using get path iterator method of shape, which returns a path iterator object that iterates along the boundary of the shape. Step 4, if the graphics 2D object cannot handle the curved segment of the path iterator object returns, then it can call the alternative path iterator method of shape alternate get path iterator method of shape, which flatten the shape. Step 5, the current paint in the graphics 3D context is queried for the paint context, which specified the colors to render in the device space. Text operations. Step 1. The following steps are used to determine the set of glyphs required to render the indicated string. If the argument is a string, then the current font in the graphics 2D context is asked to convert the Unicode characters in the string into set of glyphs for presentation with whatever basic layout and shaping algorithms for font implements. If the argument is an attributed character iterator, the iterator is asked to convert itself to a text layout using embedded font attributes. The text layout implements more sophisticated glyphs layout algorithms that perform Unicode bidirectional layout adjustment automatically for multiple fonts of differing writing directions. If the argument is a glyph vector, then the glyph vector object already contains the appropriate font specific glyph codes with explicit coordinates for the position for each glyph. The current font is queried to obtain outlines for the indicated glyphs. These outlines are treated as shapes in user space relative to the position of each glyph that are determined by step 1. Step 3, the character outlines are filled as indicated in the shape operations. Step 4, the current paint is queried for a paint context which specifies the colors to render in the device space. Image operations. Step 1, a region of interest is defined by the bounding box of the source image. This bounding box is specified in image space, which is the image object's local coordinate system. Step 2, an affine transform is passed to draw image affine transform image observer method. The affine transform is used to transform the bounding box from image space to UC space. If no affine transform is supplied, the bounding box is created as if it's already in the UC space. Step 3, bounding box of the source image is transformed from UC space into device space using the current transform. Note that the result of transforming bounding box does not necessarily result in a rectangular region in device space. Step 4, the image object determines what colors to render, sampled according to the source to the destination coordinate mapping specified by the current transform and optional image transform. The default rendering attributes. The default values for the graphics 2D rendering attributes are: for paint, it's the color of the component, font, the font of the component, stroke, a square pen with a line width of 1, no dashing, might segment joints and square and end caps. Transform, the default attribute, default value is the get default transform for the graphics configuration of the component. For composite, the default value is the alpha composite dot src underscore overrule. For clip, the default value is no rendering clip. The output is clipped to the component. Here you can see primitives, graphics 2D and output devices. Here you can see a shape is connected to stroke. Stroke is connected to transform. Transform is connected to rasterizer. Rendering hint is connected to rasterizer, and rasterizer is connected to clip. Clip is connected to paint, and paint is connected to composite. Composite is connected to screen and printer. In text, the text is connected to stroke. Stroke is connected to font, and font is connected to transform. Transform is connected to rasterizer. Rendering hint is connected to rasterizer. Rasterizer is connected to clip. Clip is connected to paint. Paint is connected to composite, and composite is connected to screen and printer. In images, images are connected to transform. Transform is connected to rasterizer. Rendering hint is connected to rasterizer. Rasterizer is connected to clip. Clip is connected to composite. Composite is connected to screen and printer. Here now this is the end of my presentation. Thank you very much for watching it.